Today we're shining a quick spotlight on Dr. Fidler, one of our physics teachers here at Franklin High, to learn more about their passion for physics and the impact they've had in and out of the classroom.
Well, I can tell you what first sort of inspired me to start looking at the world in a really physics-oriented way was my high school physics teacher, in fact. Mr. Sorensen, still remember his name after all these years. So when I finally got to a class that was like challenging, that had some math in it, that had me think about the world in a different way, I was like, oh, this stuff is pretty neat, and I learned a little bit more. And that kind of started to pique my interest in the more formal look of like studying physics. But I was never like really full force into like, oh, I want to be a physicist when I'm older type thing. I like the world of gravitation and orbits. When you start to take things and think about motion in the universe in a way that's not just, like a pencil falling at our desk, but you start to say what Newton did. If this falls, why doesn't the moon fall? And bringing that all to light through verification of Einstein's and Newton's laws of nature and how it all works together is just fascinating to me. So, you really have to be interested. You can't be intimidated by the math. I don't know all of the maths. You get very specialized as you move through, and physicists don't know everything about everything of the universe. They know what they study. All you got to do is be interested in it. And if you're interested in it, then that's 90% of the battle, because you'll be willing to put in the time. You'll be willing to learn the maths, to make mistakes, figure it out. So you need mathematical skill sets. You have to have data analysis skill sets. And you have to be able to communicate your ideas. Don't be intimidated by all the different subject areas, because you're not going to study every single subject area. Stay on top of the math, keep reading literature in the field, and it really becomes sort of like, I call it your modus operandi, right? It's just the way you're operating. My name is in space. So I responded to a NASA call for a mission, and they came out for a PR stunt to try to justify the mission to garner public support, and you could write an essay. And I won this competition, and I was added onto this list, and so my name was digitally inscripted in binary on this Kepler space program that is now aboard this telescope orbiting around the sun. I say this because a little bit of a life lesson I learned from this guy. So my freshman year, second semester, spring semester, my physics 2 professor, the young guy who was supposed to be this like prodigy, sort of this child prodigy, it was all the buzz, and everyone's like, oh, who's this new faculty? This guy's a genius, and he comes on the floor of the lecture hall that's huge, and he looked like a kind of a kid. There's 3 screens way up high around the lecture hall that we had to look at as he was deriving the equations and running through what we're doing, right? So we sit down for the lecture, and I'm like, okay, what are we gonna do? And I start taking the notes, and he starts going on his derivations, and he's standing up at his thing, and he's doing and doing and doing. Boom, 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 boom. Taking all these notes, flipping the page, more and more, flipping the page, more and more, diagram, more and more. And we got into it through an hour, right? And all of a sudden, he takes a step back, and we're like, oh, what's he doing? And he takes a step back, and he looks up at us, looks down at his notes. He takes out a big Sharpie and just all over his notes. And he's like, ladies and gentlemen, I gotta tell you, everything I wrote down here is incorrect. I made a big mistake, and I've carried it through this entire derivation, and that's why this isn't working, and I'm sorry. And at this point, we have 10 minutes left. We're just gonna end it today. Looking around like, what do you mean? So what do we do? The guy's like, just rip it out. It's not right. Just don't go back and review these notes, And I've always carried with this idea that if this young genius who was hired by a university physics department at a D1 school, who's now off in a Caltech or somewhere, if he could sit there and make an hour's worth of mistakes in front of 600 people in a physics class, and then just be man enough to admit it, recognize that, hey, we messed up, we're human beings. I was like, if he can make a mistake, it's okay for me to make a mistake. Well, I know it's gonna sound cliche, all right, but people often ask, why do you do this? Why do I work with you guys? Why am I in education? Why am I teaching? Why do I do this type of work? I enjoy it. And I really can't imagine working in other places in a sense like a corporate office environment. Like it's just not my thing, right? And so there's days you can have good days and good days you'll have bad days. But one days I really like and enjoy is just simple things. But when we were doing a lab the other day, when we were building those paper roller coasters, right? We were putting the marbles down the paper roller coasters. And you guys have built these things, right? And you're writing on the sheet, right underneath like the track, the various energies represented at each point on the track. And when I look around, I see students taking measurements and massing the marbles. But as you're working through these problems, students are like, oh yeah, I get it. When I start to see students like, oh, I'm not just talking about like solving a problem. Like anybody can solve a math problem, right? But when you start to really fundamentally know what it means, it's what you're understanding is that we are encoding the universe in a mathematical palette. It's right in front of you. It's not me on the board writing some theoretical problem, right? It's you guys doing it. And when I see that aha moment, I said, oh yeah, I get it. Yeah, that's like what we're trying to get you to recognize, right? Is super powerful to an individual's sense of learning, right? And I think it brings a lot of new wirings into the brain and helps students meander through this world of physics. It provides me with a good sense of sort of satisfaction. Like, yes, we are learning about the physical universe that we all exist in together, and it's a pretty powerful moment.